Hello and welcome to AgUniter. This is the lecture number 3 on robotics engineering, and we will going to discuss about robotics anatomy. What is anatomy? Anatomy is the scientific study of a human arm or an animal. In this image, we have two parts. First one is a robotic manipulator known as a Puma robot, and second is a equivalent human parts. By analyzing the human parts, we have a joint at a shoulder, then we have a joint at an elbow, then we have a joint at a wrist, and we have a number of joints at the hand and fingers. And this all joint provides some motion to the human parts, human body. These all joints provide some motion to perform some tasks at a different orientation and different angle position. In a figure A, this manipulator consists of joints and links. This link 0 is known as a base link, connected with link 1 with the help of joint 1. Link 1 and link 2 also connected with joint 2. So we can say is a combination of links and joints. Any robotic manipulator is the combination of number of links and number of joints. This number of links and number of joints are dependent on a requirement of the system. What type of motion we want, what type of orientation we have. The motion requirement and the orientation requirement is fulfilled by different number of joint and links. Here the joint provide relative motion to the body. Here is a joint at a shoulder, and this joint provide the movement to the shoulder to body. Similarly, this base link and link number 1 have a relative motion, and this relative motion provided with the help of joint 1. Then links are a rigid member between the joints. Then we have a different type of motions like a linear and rotary motion. On the basis of this, we will select the types of joints to satisfy our requirement. Each joint provides a degree of freedom to the system. Each joint provides a degree of freedom to the system. Say, here we have a joint number 1 at this particular point. This is the joint number 1. And here we have a joint number 2, then we have a joint number 3, then we have joint number 4, then we have a joint number 5, then we have a joint number 6. So total 6 joints is present in a Puma robot. So we can say this robot has a 6th degree of freedom. This robot has a 6th degree of freedom. In a human arm, we have a joint number 1 here, then we have joint number 2 at here, then we have joint number 3 here, then we have joint number 4 here, then joint number 5 here, and n number of joints are here. So by adding all the joints, we can get the degree of freedom of the human arm. A robot manipulator consists of 2 sections. First is an arm or a body, and second one is the wrist. The body and arm are used for the positioning of object in a robot's work volume, whereas wrist assembly is used for the orientation of the objects to perform an operation at a desired location, whereas wrist assembly is used for the orientation of the object to perform a desired operation at a desired location at a desired angle. Next is the robotic joints. Different type of joints used by a manipulator in a robotic system. These joints are classified on the basis of motion First one is a translation motion. First joint is a linear joint. First, let me draw the linear joint. This is the link number 1. This is the link number 1. And this is the link number 2. This is the link number 2. The H1 is a link number 2. The axis of link number 1 and axis of link number 2 are coincide to each other. And this link number 2 perform a motion along the axis of the coincide axis. The link 2 slide or move along the coincide axis. So this type of arrangement is called a linear joint. The next joint is a orthogonal joint. In an orthogonal joint, the two links are perpendicular to each other. This is the link number 1, and this one is the link number 2. Link number 2 and link number 1 are perpendicular to each other, or we can say is orthogonal to each other, and this link number 2 slides over the link 1. So this type of arrangement is called a orthogonal arrangement. Then second motion is a rotary motion. For the rotary motion, we have a first joint is a rotational joint. Let me draw the rotational joint first. This is the link number 1, and this hashed link is a link number 2. The axis of link number 1 and link number 2 is coincide to each other. The axis of link number 1 and link number 2 is coincide to each other, and the rotational axis is perpendicular to your screen. The rotational axis is perpendicular to your screen. This link is rotated like this, and this axis of rotation is perpendicular to your screen. So this type of joint is called a rotational joint. Now, next is a twisted joint. In a twisted joint, the link number 1 and link number 2 are collinear to each other. The axis of link number 1 and axis of link number 2 are coincide to each other. And the link 2 is rotated about a coincide axis. Link 2 is rotated about a coincide axis. Here, the link 2 is rotated about the axis which is perpendicular to coincide axis. Here, the link 2, this is the coincide axis, and the link 2 is rotated about this perpendicular axis. But here, the link 2 is rotated about this coincide axis itself. So this type of joint is called a twisted joint. Next is a revolving joint. In a revolving joint, the two links are orthogonal to each other, or we can say the axis of link number 2 and the axis of link 1 is perpendicular to each other. The axis of link number 2 and axis of link number 1 is perpendicular to each other, and this link 2 and this link 2 is rotated about a axis number 1, and this link 2 is rotated about a link number 1. So this type of arrangement is called a revolving joint. Thanks for watching.